How do I even use the ideal gas law? Welcome to Curly Carbocation. Please subscribe and stay tuned. If you're an algebra hater like me, buckle up because there's a lot of algebra with this. You've probably already learned the ideal gas law to being PV equals nRT or PV-nRT. Now this equation is of no use to you as any other equation in science if you don't think of them in this way. In science, equation has a synonym. That synonym is relationship. The way I've explained it to the high school students that I've tutored is like, think of your family. If this other person is your brother, then you share the same mom. Your mother's mom is your grandmother. You and your first cousin share the same grandmother. And your daughter is your mother's granddaughter and your grandmother's great-granddaughter. And that's how you need to think of multiple components within the same equation. Because an equation tells you how all these terms are related to each other. Now for all you algebra haters like me, you need to start practicing algebra because the rest of science depends on it. Just simply, what this says is if this side goes up, this other side goes up. And if this side decreases, this side also decreases. Now the question is, which component on each side is increasing or decreasing? In any problem in life, you will hear several times, oh, there's just so many factors, so many components as to why this problem is a problem. But now as math gets more difficult, you are honing in your problem-solving skills to figuring out exactly which thing is affecting another thing. So practicing your algebra skills in this is actually helping you to become a better problem solver even if you don't use chemistry in your real life. You are much less susceptible to taking excuses and now you force everyone to be personally responsible, something we all need. So if your problem is isolating one of these things, you can assume that the other thing is increasing or decreasing. Now, R isn't going to change, so it's either moles or temperature that is going to increase or decrease. But take it one step at a time and look at your problem. See which components are listed. Is it temperature? Is it moles? Is it volume? Look at it. Don't just look at it. What is it trying to ask you? Are you trying to determine the volume? If so, rearrange the equation so it brings you volume. Is it asking you for mass? Well, then rearrange for moles and then convert with molecular weight later. What about pressure? What about pressure? It's just like finding volume, except now it's the pressure component. And by now you can probably guess what we're gonna do for temperature. Divide both sides by nR to get T by itself. I'd say until up about high school biology, math and science are relatively separate. But the further along you go in science, the more you need to use math to prove all your theories. To all you algebra files, this makes sense. To us algebra phobes, this looks like absolute gibberish. Don't worry, algebra phobes, I've already taken 4 calculus classes, 2 statistics classes, and 2 differential equations classes. The lesson is that it's not impossible for an algebra phobe to be good at algebra, but it does take practice. And chemistry, which is heftily thermodynamics, requires a lot of algebra. If you aren't already enrolled in chemistry, enroll in Algebra 2 first, and then chemistry will be way easier. If this video helped you, please give me a like and I will see you next time. Bye!